Hello everybody, welcome into another lesson. So today we are going to do a 3-lesson series on graphing rational functions. So yesterday's lesson was more of an introduction to very basic rational functions. In general, rational functions fall under one of 3 types. There are 3 types of them. Today's type we're going to talk about is a rational function in which the degree of the numerator is less than that of the degree of the denominator. There's also the type which we'll talk about in the next lesson where the degree of the numerator is equal to the degree of the denominator. And then the lesson after that we'll talk about when the degree of the numerator is greater than the degree of the denominator. But today we're only talking about rational functions, graphing those in which the degree of the numerator is less than the degree of the denominator. So here in general you have f of x equals a rational function where you have a being some coefficient on your x variable. You have x to the m power plus b to the x to the m minus 1 power, so it's one less power than the previous term, and it could keep going on and on. All that divided by some other coefficient c, where you have x to the n plus d to the dx to the n minus 1, etc. In this particular setup, the degree m in the numerator is less than that of the degree n in the denominator. If the degree of the numerator is less than the degree of the denominator, your horizontal asymptote is always going to be y equals 0. It'll always be that. So even the type we did yesterday applies to this. Like you have f of x equals 2 over x. Well, how does that work if you have a constant term? Think of it this way, right? So let's just break this down a second. So f of x equals 2 over x, right? Okay. Well, isn't x to the 0 1? Really, we could think of this as 2x to the 0 over x. Well, we know anything raised to the 0 power is 1. So that's, you get 2 times 1, which would just be 2 over x. And of course we know the function wouldn't be defined when x is 0, so we're not even going to consider when x is 0. For all purposes here, we'll say x is anything but 0. So that means x to the 0 would be equal to 1, therefore just giving you a constant value of 2. So that's how that works even for constant terms in the numerator. It's the same as x to the 0 power, which would be less than the degree of the denominator being to the first power. But let's go ahead and review here a little bit with this one, then we'll move on to some other ones. So we have here f of x equals 2 divided by x. Well, first find your vertical asymptote. If we remember, that's when you take your denominator, set that equal to 0, which would just give you that x equals 0. So we have a vertical asymptote when x equals 0. And then since the degree of the the degree of the numerator is less than the degree of the denominator, you have a default horizontal asymptote of y equals 0. So you'll have a horizontal asymptote at y equals 0. So that's pretty easy. Now let's just go ahead and plot this here. So x can't be 0. We have a vertical asymptote at x equals 0. But what about when x is 1? So you get 2 divided by 1, which would give you a y value of 2. Alright, what about when x is 2? 2 divided by 2 is 1. When x is 3, you would get 2/3. When x is 4, you would get 1/2. And you see it keeps getting infinitely closer and closer to a y value of 0, that horizontal asymptote of y equals 0. Now, what about when x is 1/2? 2 divided by 1/2 would be 4. So you'd be all the way up here. Then 2 divided by 1/3 would be 6. That would be up here. And you see it gets infinitely closer and closer on the left side to that x value of 0, but it doesn't actually reach it. Now let's go to when x is negative. When you have negative 1 for x, well, you would get a y value of negative 2. When x is negative 2, you would get a y value of negative 1. When x is negative 3, you would get a y value of negative 2/3. Then when y is negative 4, you would get a y value of negative 1/2. So you see, going further left, it gets closer to that y equals 0, but it can't quite reach it. Alright, what about when x is negative 1/2? We get negative 4 for y. Then when x is negative 1/3, we get a y value of negative 6. So the further right we go, we're closing in on that x value of 0, but we can't quite reach it. But herein is the total graph of f of x equals 2 over x, based on our asymptotes also. Now, let's do some other functions where the degree of the numerator is still less than the degree of the denominator. Alright, so what if, let's say I gave you x over x squared minus 9. So we have x over x squared minus 9. The degree of the numerator is still less than the degree of the denominator, so these rules will still apply. However, you have a linear term in the numerator and a quadratic in the denominator. So again, we're going to find our vertical asymptotes. So to do that, you take your denominator, set it equal to 0. That means x squared minus 9 equals 0, which could factor into x plus 3 times x minus 3 equals 0, which means x would equal both plus and minus 3. You actually have two vertical asymptotes. So yes, you can have two vertical asymptotes. Those are both going to be found at plus and minus 3. When x equals plus and minus 3, you'll get two vertical asymptotes. So let's go ahead and draw those asymptotes on the graph. Alright, now we also have when x equals positive 3. That's yet another asymptote. Alright, so we've got both of our vertical asymptotes. Now, since the degree of the numerator is less than the degree of the denominator, we have a horizontal asymptote. So the horizontal asymptote can be found at y equals 0. So two vertical asymptotes where x equals both plus and minus 3, and then a horizontal asymptote at y equals 0. So let's graph this bad boy. Let's start to the right of x equals 3 when x equals 4. So let's do f of 4. What's that going to give us? Well, that would give us 4 over 16 minus 9, which would equal 4/7. So at 4, we get 4/7, which is a little over half. Alright, what about when we have 5? Let's do f of 5. So f of 5, that's going to be 5 over 25 minus 9, which would equal 5/16. That's under half and a little under a third even. So you notice it's starting to get infinitely closer and closer to that y equals 0 horizontal asymptote. Now, let's say I did, why don't we this time go in between 3 and 4? So 3.5, which is going to be 7/2. So let's take f of 7/2. That's going to equal 7/2 all over, that would be 49/4 minus 9. Well, that's going to equal 7/2 all over, what is 9 in terms of fourths? That's 36/4. So you'd have 7/2 over 13/4, which would equal 7/2 times 4 over 3, which would end up giving you 14/3, which is just a little bit south of 5. That would be 4 2/3 when x is half, 3.5 rather. So it does a very sharp jump upward towards that asymptote of x equals 3. Okay. So now let's go in between -3 and 3. Let's figure this out. So what about when x equals 2? So let's put in f of 2. F of 2, well, that would end up being 2 over 4 minus 9, which would end up giving you -2/5. So when x is 2, y is -2/5, so that's a little under half. All right. Now, let's do when x is 1. So let's do f of 1. That would end up being 1 over 1 minus 9, which would be -1/8. That'd be getting even closer to that y equals 0. Now, of course, then if we did f of 0, it should be pretty obvious that we would get 0. All right, now what about when x equals -1? Let's do -1 for x. So if we do that, that's going to be -1 over 1 minus 9, which would end up being +1/8. So at -1, we would get +1/8. Now what about when we did -2 for x? So let's go ahead, put in x equals -2. All right, so that'll turn into -2 over 4 minus 9, which would actually be +2/5. So that'd be a little south of half. Okay. Now, let's go in between -2 and -3. So -2.5, that's going to be -5/2. So we're about to have a hot mess here. -5/2. What's that going to look like? That's going to look like -5/2 all over 25/4 minus 9. Well, what is 9 in terms of 4? That's 36/4. So this would be -5/2 divided by -11/4, which would turn into -5/2 times 4 over -11. Well, the negatives cancel out, which would end up giving you 10/11ths, which would just be a little bit north of 1. In fact, you would find that the further left you go here, it's going to curve upward, and the further right you go from 0, 0, it's going to start to curve downward. So you get almost what looks like a negative x to the third power type of graph for the middle zone here between x equals negative 3 and x equals 3. Now, what about if we did x equals negative 4? So let's go ahead now and go to the left of x equals negative 3. So f of negative 4, that's going to equal negative 4 over 16 minus 9, which would end up equaling negative 4/7. So at negative 4, you end up getting negative 4/7, which is a little south of halfway there, between 0 and negative 1. Let's do negative 5, when f is negative 5. Alright, so that would give us negative 5 over 25 minus 9, which would end up giving us negative 5/16, which would be a little less than a third, and getting infinitely closer and closer to 0, but not quite reaching it. And then if you went to the right, if you went in between negative 4 and negative 3, it would start to curve downward towards x equals negative 3, but not quite reaching it. So really, this is what the graph of f of x equals x over x squared minus 9 would look like. So in general, whenever you have a linear over a quadratic, this is generally what you tend to get. You tend to actually get 3 pieces, which I think is kind of cool. So, and there's more. There's more where this came from. All right. So what if we had something like 2x plus 3 over x to the third? Okay, so this time we have 2x plus 3 divided by x to the third. So the power of your numerator is still less than that of the denominator, so your horizontal asymptote rule is going to apply. So your horizontal asymptote's easy. That's going to be 0. Since the degree of the numerator is less than the denominator, you'll get a default horizontal asymptote of y equals 0. Now, your denominator, you want to, of course, find your vertical asymptote. Well, x to the third set equal to 0, that just gives you x equals 0, right? So your vertical asymptote will be at x equals 0. You only have one vertical asymptote in this case, so x equals 0. So that actually isn't too terrible. So let's go ahead and start plotting this. So let's pick x equals 1. So f of 1, that's going to end up then giving you 2 plus 3 over 1, which would just be 5. So at 1, we're all the way up to a y value of 5. All right. Now, what about when we pick 2? Let's pick x to be 2. All right, so in the numerator, 2 times 2 is 4, so we'll get 4 plus 3 over 2 to the third, which is 8. Well, that's going to give you 7/8. So when x is 2, you're all the way down to 7/8. Now, what about when x is 3? Let's go there. So if x is 3, okay, so 2 times 3 is 6. You'll get 6 plus 3. Now, what is 3 to the third? That's 27. Well, this would end up giving you 9 over 27, which would literally be 1/3. So when x is 3, you're down to 1/3. And you see you keep getting infinitely closer and closer to 0, to that y equals 0. And then you have a very sharp turn up here the further left you go. It almost looks like a linear rational function for the denominator, only it's much sharper curve. Now, let's put in some negative values. So let's do f of -1, right? So when we got -1 for x, that would give you -2 plus 3 all over, what is -1 to the third power? That's going to be -1. Well, okay, so 2 minus 3 is what? -2 plus 3 is 1, divided by -1, that's going to give you -1. So, basically then, you have at 1, you get -1. -1, you get -1 rather. Now, something very interesting is going to happen here. Let's pick -2. So, okay. 2 times -2 is -4 plus a 3 divided by, now what's -2 to the third? That's -8. That would end up giving you -1 divided by -8. You actually get positive 1/8. Well, what happened? Isn't y equals 0 the horizontal asymptote? It is. It sure is, but horizontal asymptotes in rare occasions can be crossed. Overall, they do tend to guide the shape of your curve, but they can be crossed. The ones that absolutely cannot be crossed are vertical asymptotes, because that would truly make your function value undefined. But however, horizontal asymptotes actually have been known to be crossed. It can happen that way. Alright, let's pick -3. So what about when we get -3 for x? Well, 2 times -3, that's -6 plus 3. All over, what's -3 cubed? That's -27. This would end up giving you -3 divided by -27. That'd be positive 1/9. So at -3, you'll actually end up getting positive 1/9. And then let's pick -4. Let's pick one more. How about when x equals -4? So that would be like -8 plus 3 all over -64. Well, that would give you positive 5/64. Real small and real close to 0. So here's what's going to happen. To the right of -1, it's going to get real close to that x equals 0. And then it's going to temporarily cross y equals 0, and then it's going to loop around to ride the asymptote above y equals 0. That does sometimes happen, because if you keep putting in increasingly negative values for x, what will happen is you'll get positive y values, but smaller and smaller fractions, meaning you're getting closer and closer to 0. So this is a freak occurrence where you can cross a horizontal asymptote. That is entirely possible, but it doesn't happen often. All right. What about, let's see here. We have 3 divided by x to the third minus 27. We have 3 divided by x to the third minus 27. So the degree of the numerator is less than the denominator, so it's very clear that our horizontal asymptote will be y equals 0. That's an easy one. Now, what about for the vertical asymptote? So we have to take x to the third minus 27, set that equal to 0, right? Well, here's the thing. When it comes to graphing, we only care about the real solutions when it comes to graphing. We know we could factor this as a difference of 2 cubes. You'll get, of course, one real factor, but so if we factor x cubed minus 27, we know this would break down into x minus 3 times the quantity of x squared plus 3x plus 9 would be equal to 0, right? Difference of 2 cubes. But your quadratic factor, you got to use the quadratic formula, which you're going to get 2 imaginary solutions. We don't care about the imaginary solutions because they don't help us with the graph. We only care about the real solutions. So you'll have a vertical asymptote at x equals 3. Vertical asymptote can be found at x equals 3. So let's go ahead and plot that. All right, there we go. So let's go to the right of x equals 3. So let's start at x equals 4, right? So we'll put in f of 4. F of 4, well, that's going to equal, of course, 3 over what is 4 to the third? That's 64 minus 27. Well, what is 64 minus 27? That's 37. So you would end up getting 3 37ths. That would be really small. You'd end up getting 3 37ths. And then why don't we do f of 5? So we'll do f of 5. So that would be 3 over, now what's 5 to the third? That's actually 125. Then that'd be minus 27. That would be 3/98, which is even smaller yet. It's just getting closer and closer to 0. In fact, your curve would go sharply up like that towards x equals 3, but not quite reaching it. And then getting closer and closer to that asymptote of y equals 0. Now, let's go to the left of x equals 3. We'll start with x equals 2. Whoops, I don't want to kill off the asymptote. We want to keep that. But what about when x equals 2? So f of 2. So at x equals 2, this would be 3 over, okay, now what's 2 to the third? Well, that's going to end up being 8, so 3 over 8 minus 27, which would turn this into negative 3/19 for when x is 2. So let's go to 1. How about when we get when x is 1? Alright, so that'd be 3 over 1 to the third is 1, so 3 over 1 minus 27, that'd be negative 3/26. That's getting even smaller. And as you see, it would get closer and closer. Well, that's very, yes, so it's going to get even smaller and smaller and infinitely closer to 0, but not quite reaching 0. If I put in x being 0, I would literally get negative 1/9. If I put in negative 1, I would end up getting negative 3/28. So you see, it just keeps getting smaller and smaller and smaller, closer to 0, but not quite reaching it. So to the left, it'll ride that horizontal asymptote of y equals 0. To the right, it'll ride the vertical asymptote of x equals 3. So that's what the graph's going to look like for this one. All right. Definitely don't want to do that one. Good one. This is a good one to demonstrate here. Negative 24 divided by x squared plus 8. This is a very good one. So negative 24 divided by x squared plus 8. So we have, of course, the degree of the numerator is less than the denominator. So your horizontal asymptote is y equals 0, right? That's by default. You'll have the horizontal asymptote of y equals 0. So what about your vertical asymptote? X squared plus 8 equals 0. Well, if you go to solve that, you'll get x squared equals negative 8, which would give you two imaginary solutions, which don't count. So really, you have no vertical asymptote, and you will have that sometimes. There is no vertical asymptote for this particular one. So that's why it's important to set your denominator equal to 0. There will be times you won't have a vertical asymptote. You only have a horizontal. So let's go ahead. Let's start at x equals 0. So f of 0, what do you get? So that's going to give you literally 24 over 0 plus 8, which would be 24 over 8, which is 3. I'm sorry, negative 24. So that would give you negative 3. So at 0, you have a y-coordinate of negative 3. All right. Now, why don't we go for f of 1? Well, let's see. 1 to the second power is still 1, so that'd be negative 24 over 9, which would be negative 8 thirds. You would end up at negative 8 thirds for f of 1. So that'd be negative 2 and 2 thirds. All right, now what about when we do f of 2? F of 2, well, 2 to the second is actually 4. So this would turn into negative 24 over 12, which would just give you a y value of negative 2. So at f of 2, you'll get negative 2. All right, now what about, let's do 3 for good measure. So let's see, f of 3, all right, so what is 3 squared is 9. This would give you negative 24 over 17, over positive 17 rather. So that's like negative 1 and 1/17, negative 1 and 7/17, which would be a little less than negative 1.5. It'd be a little bit north of negative 1.5. Okay, let's do 4. Just for good measure. Let's put in f of 4. So 4 squared is 16. You would have negative 24 over 24, which would give you a y value of negative 1. When you do f of 4, and if you did f of 5, you would be going to the north of negative 1, getting closer to 0. So here's how that's going to shake out on the right-hand side. It's going to get infinitely closer and closer to that y value of 0 on the right. And notice something. If you took the negative values of f, well, let's do that here real quick. So what's f of negative 1, right? Negative 1 squared is still 1. So negative 24 over 9, that'd be negative 8 thirds. You'd end up at negative 2 and 2 thirds for negative 1 when x is negative 1. Then if we did negative 2, you would end up getting negative 24. So what's negative 2 squared? That's positive 4. negative 24 over 12 would end up giving you a y value of negative 2. So at negative 2, you'd be at a y value of negative 2. And then you see how this just kind of loops around, getting closer and closer to eventually where y equals 0, but it never actually reaches it. You almost get this bell-shaped, heel-shaped curve here, but it can't quite reach y equals 0. So that's, I think, a really cool graph. It almost looks like a bell or a hill, whatever you want to consider that, or like a valley in this case, but that was actually a pretty cool curve. I feel like we should do at least one more. Yeah, let's do this one. F of x equals 4 minus x all over 5x squared minus 4x minus 1. So f of x equals 4 minus x all over 5x squared minus 4x minus 1. Okay. Well, we know our horizontal asymptote is going to be y equals 0 because the degree of the numerator is less than the denominator. That's a given. So the horizontal asymptote is definitely y equals 0. Now, what about your vertical asymptote? So we need to take the denominator, set that equal to 0. So 5x squared minus 4x minus 1 equals 0. This should factor 5x squared plus x minus negative 4x minus 1. Good. Okay. So we have this factored into x minus 1. That quantity times 5x plus 1 equals 0. Well, x minus 1 equals 0 would give us that x equals 1. And then 5x would equal negative 1, means x equals negative 1/5. So we actually have two vertical asymptotes again. Vertical asymptotes are at x equals negative 1/5 and positive 1. So that's going to be kind of funny, the way this is going to look. So negative 1/5, yeah, about right there, I would say. Draw this as straight as I can. It's not the straightest, but it could suffice. So x equals negative 1/5, right about there. Then x equals positive 1 is yet another asymptote. So we have two vertical asymptotes very close to each other. So that's going to be some very tight squeezing. Now, we got our asymptotes. Why don't we go ahead and start inputting some values? Let's go to the right of x equals 1. Let's kind of make this easier on ourselves. So all right, so I think we're going to come up here. Let me rewrite those asymptotes since we know what they are now. We did the factoring work. Vertical asymptotes are at x equals negative 1/5 and 1, because I want to use this space down here to input function values. All right, so let's put in f of 2, right? Let's try an x value of 2. What's that going to give you? That would give you 4 minus 2 all over 5 times 4 minus 4 times 4 minus 1. Okay, well, what's that going to give you? That would give you 2 over 20 minus 16 minus 1, well, that would give you a value of 2/3. So when x is 2, you get a y value of 2/3. All right. Now, you guessed it, we're going to do 3. What about when x is 3? So that would give you 4 minus 3 all over 5 times 9 minus 4 times 3 minus 1. Well, that would end up equaling 1 over 45 minus 12 minus 1. So let's see, that would give you 1/32. You'd end up with a y value of 1/32 for when x is 3. X is 4, I think, is a no-brainer. You would literally be at 0 when x is 4. Now, what about 5? This is where it's going to get very interesting. What about if we did x is 5? So f of 5, that's going to give you 4 minus 5 all over 5 times 25 minus 4 times 5 minus 1. Well, what is 4 minus 5? That's negative 1 over 125 minus 20 minus 1, which would end up giving you negative 1 over 104. So when x is 5, you have a y value of negative 1 over 104. And then 6, let's just do f of 6 for good measure. It's still going to be a mess, but so 4 minus 6 over 5 times 36 minus 4 times 6 minus 1. So 4 minus 6 is negative 2. Now what is 36 times 5? That should end up being 180. Yep, so 180 minus 24 minus 1. All right, so that should end up giving you negative 2 over 155. So that should put you even closer to 0. So what's going to happen here is you're going to cross the horizontal asymptote of y equals 0 and pretty much just ride it to the south. And then further north of the y equals 0, when x is 4, you'll end up getting close to that line. So you do cross, you get a little bit close to x equals 1, but it does cross the horizontal asymptote when x is 4. And it goes a little bit further south of y equals 0, but rides the line. Now, here's where we're really in for some fun. This is really going to get fun. What about when x is 0? So f of 0, well, that's literally going to equal 4 over negative 1. That would give you negative 4. So when f is 0, you'll end up getting negative 4. All right, now let's do 1/2. Because we technically are going to have a middle piece. We technically are. Because we have 3 asymptotes. This is not going to be fun. So we'll have 4 minus 1/2 all over 5 times 1/4 minus 4 times 1/2 minus 1. So let's see, that would end up being 7/2 all over 5/4 minus 2 minus 1, which would give you 7/2 all over 5/4 minus 3, which 5/4 minus 3, that ended up giving you 7/2. Yeah, I'm running out of room. This is where it can get a bit hairy if you're not doing it on a graphing calculator. So 7/2 all over negative 7/4, which would turn into 7/2 times 4 over negative 7. You would literally end up getting negative 2. So at 1/2, you would get negative 2. Now, let's get even more technical. What I would like to know is, does this cross the x-axis at any point in between? Let's try f of 1/4. Yeah, we're going to do 1/4, okay? So let's try x equals 1/4. So we'll have 4 minus 1/4 all over 5 times 1/16. Now what is 4 times 1/4? That would be minus 1 minus another 1. That would be equal to 15/4 all over 5/16 minus 2, which would end up giving you 15/4 all over negative 27/16, which would end up giving you 15/4 times 16 over negative 27, which would end up giving you negative 60 over 27, which both divide by 3. You would end up getting negative 20 over 9, so negative 2, and you'd end up getting negative 2 and 2/9. So you'll actually dip further south again here. So you almost have like a parabola to the south. You can sometimes have that where you almost get like a parabola type of thing to the south there in between the asymptotes. Now let's go to the left of negative 1/5. Let's do x equals negative 1. So let's do f of negative 1. Well, that 4 minus negative 1 is 4 plus 1, which is 5, all over, let's see, that would be 5 times 1 minus 4 times negative 1 minus 1. So that's going to give you 5 over 5 plus 4 minus 1. Well, that would give you 5/8. So you would have a y value of 5/8 when x is negative 1. Now what about we do negative 2? Alright, well, 4 minus negative 2 would turn into 6 over 5 times, let's see, that'd be 4 if you take negative 2 to the second, minus 4 times negative 2 minus 1. Well, this would turn into 6 over 20 plus 8 minus 1. Well, that would give you 6/27, which would give you 2/9. So that's less than half. In fact, you're going to ride real close to 0 to the left. You'll ride that horizontal asymptote here, but you'll never cross it again. Why is that? Because you'll have all positive values the more negative numbers you put in, and it'll come up and get close to that asymptote. So, of x equals negative 1/5. So this is what the graph of this funky looking thing would look like. But that's it for graphing rational equations where the degree of the numerator is less than the denominator. Next lesson, we're going to graph rational functions where the degree of the numerator is equal to the degree of the denominator. So I hope everyone has a great day. Take care.